as well. Okay, we'll wait a few more minutes and yes. Hello, Sod. Maybe start at 9:05. Today is mostly demo, just showing some different ideas and maybe you'll all have some ideas too. Yeah, it'll be fun. Has anybody here used Max MSP at all? Any users? I purposefully designed this for people who maybe don't use it because it takes a lot of time to learn. It is fun. It's like puzzles. I find it's like just a way to do puzzles all day, to like make little devices. And there's actually a very active Discord for Max too. All right, let's start. Okay. All right, thank you everybody for being here. This is session 3 of sequencing and generative composition. Let's move along. Today's agenda, so I'll just quickly do the same thing about the intro just in case anybody hasn't been here before, but I'll go through it quickly and about the course, and then we're just going to dive into demo. There's also a quick just recap of last week, so let's just go. Let's get into it. So just a tiny bit about me. Many of you already heard this, but I live in Los Angeles. I make music and I do a lot of audiovisual work now. I come originally from long ago DJing background, and then I got into music producing, kind of just using Ableton and little groove boxes. I think the first drum machine I ever had was the Korg Electribe, and then I started using Max, and now I use Max a lot for all kinds of things, including visual work, and now including music as well. I, for a long time, just used Max as like glue in my studio. Like, oh, I had this one drum machine that needs to send MIDI to this other one, but like there's like a mismatch in how one interprets the protocol or something, and so then I would just use Max to kind of do this translation. So for a long time, it was basically being used as a utility thing. But in the last couple of years, I've been doing more creative stuff in Max. And I'm doing this course really to just share what I've been up to, sort of artist talk style, and then also organize my own brain a little bit because I think it's helpful. All right. And if anybody wants to introduce themselves, please feel free. You can either jump in, I'll leave a little space here, or just in the Skillshare, or not, whatever you like. Hydrating is very important. Cool. The problem-solving side is very important. Artists need that community development. Cool. Yeah. I'm sorry, say that again? Yeah, so important. I think here, I mean, in Los Angeles, just as an aside, like we have so many music makers and so many artists, but what we are lack a little bit is that sort of like fabric of the community and the things that connect people. Because in part because it's such a big city where so many big artists come through. So it's like there's tons of shows from like foreign artists and places from other places, but the local scene is sort of um, the local scene needs a little bit of love from people like yourself. It's a lot to give. Cool. Do you have what is your sort of what attracted you to Max? Like what was it that made you that piqued your interest about it? Cool. Yeah, I'd say that's very similar to me. I One thing I actually almost struggle with is it's so fun and easy to just build more stuff that sometimes I have to remind myself to actually do the music part, which I equally like, but in a way it's like more challenging to kind of do creative work. It's just tougher on the sort of to get yourself into the headspace, whereas the building can kind of happen really easily, I find. Um, but yeah, I'm motivated that same way of just it's so fun to solve those little problems. Cool. Yes, I've heard that as well. You're welcome. Anybody else? I can't see the chat. I guess I could pull the Discord window actually over. Let me do that. Okay. If not, that's okay too. Sod has been active in here. All right. Well, if you change your mind, Sod, just shout. We're uh, we're here. I don't know what that sound indicates. I didn't hear that. Will you repeat it? I for some reason didn't hear that. I have no idea. Cool. Cool. Thank you. Yeah, I don't know why I can't hear it. It's not a level thing. I think it's like I'm not hearing any of it. Anyway. Yeah, totally. Okay. Great. I love how international this group is. That's great. All right, moving along. We've shown this in the past, and I think most of you have actually seen all of this, but just to reiterate it, right? Complete openness and acceptance here. And especially in this session, I think, as we go through things, like if you have a question, if you don't understand something, if you want to know, jump in, because I think there's a bunch of demo, but I don't have to get through all of it, and I don't even think that if I were to go through all of it, I would fill the full time. So very much discussion encouraged, and feel comfortable. Please feel comfortable asking questions. And if your audio, if I'm not hearing you, because now that we know that I have some type of issue receiving people's audio, just go into the Skillshare, because I have that open, the Skillshare chat. Okay, and you all know this. So quickly, last week we talked a little bit about this theory, quote unquote, this idea of inside and outside time, and then this notion of getting from the sequence or the pattern up to the full composition, and what are the ways that we might do that. And for me personally, I started doing what I'm doing in part because I just wanted to build things, as mentioned, but also because I was interested in getting beyond some of the limitations that exist in the equipment that I was already using, which was these drum machines. And I think, as I mentioned, I love those machines. I think their limitations are good, but I was interested in sort of a new mode. And I think what's been interesting as I've actually gotten into making this thing is discovering that some of my goals that I had are going to be difficult to achieve. Maybe someday that I will, but that there are sort of other benefits to these kinds of systems. So as we get in, I'll be able to show a little bit better. And we talked a little bit about Max and kind of where it comes from, who started it, what it's like to use it. And next session in particular, like we'll go kind of, I was planning on spending next session just doing resources. So just talking about, if you want to learn this, where do you do that? Where's the community located, all that kind of stuff. So we'll talk more about that. And then we did a quick demo last time. But today, that's what this is really about. So I'm going to switch over my view to that. Great. And hopefully this time you should also be able to see my pointer, because in the past you haven't been able to see it. So, yay, good. Okay. So let's do start with our simple sequence. We saw this last time, but I'll show it again. So just to understand, so I have a clock. I have these different tabs. First off, let me just give a few basics. In most of these cases, this clock is in charge of driving everything. You can think of it like it's the Midi clock. It's basically just sending a number. So you can see this number here, a counting number. And the way that this thing is actually built specifically is that this clock 1 object here is actually just sending like a saw waveform. And you can see, and it's going from 0 to 1. So let me actually do this. I'm going to change it so that it's showing us the range of 0 to 1. Okay, so this is actually an audio signal that's moving very slowly between 0 at the bottom and 1 at the top. And this is how we get a clock, because basically every time that this signal goes back down to 0, that's a new bar that's being started. And I can show you, if I increase the tempo to say 300, you can see now that it's a shorter wave. If I lower it to say like 20, very slow, you can now see that this is increasing very slowly. And then you can also, of course, see that these counters are advancing at now a slow speed. And if I go to say 125, now a faster speed. So this is sort of the timing generator for the entire system. You can certainly have multiple of these. In practice, I typically only use one. But one of the ideas I had, that's actually a good example, one of the ideas I had about why I wanted a system like this was so that I could have multiple sources of time, multiple clocks. I'm having a hard time figuring out why that's actually musically interesting. So I don't do it that often, although I'm sure others could. I'm just not having success with that particular technique. This device is the clock divider. So basically it gets this ramp, this kind of saw waveform. And it also gets the transport. So basically, is the device running or not running? And I can show you. So if I do off, if I do on, this is going to be lit. If I do off, it's not going to be lit. So it's just sending a 0 or a 1. And then this connection is sending the what I call the quantum, what you might also call the subdivision. It's basically understanding what is a bar, what is a beat, right? Because if we say 125 beats per minute, right? And we have this, oh yeah, I didn't mention that. This is a beats per minute, 125. The waveform here, every time it goes, is a bar. And so the question is basically, what is a beat? How many beats are there in a bar? And in this case, we're using the standard 4, but I could actually change that, and it's gonna influence how the sequencer operates. But let's keep it at 4 because it's a little bit easier to understand. And then what this device does is just it allows me to have multiple divisions of that. So this is right here. What we're seeing is basically the 16th note pulse. So there's 16 of these numbers output for each cycle of this saw wave. But we could also do 30 seconds. So you can see this one here on the right is the 16ths, and this one is moving twice as fast. We can do the ultra fast one over here is the 128th note. That one's really fast, and then we have just every bar over here moving really slowly. So the reason that this is useful is now we can sort of have our patterns that are generated at a certain interval, but then if we have other events that need to happen that happen less frequently, for example, we can use a slower signal in order to do that. The 128, like the super fast one, can often be useful for like modulation, which I'll show you an example. Like if I have an LFO, I'm actually going to sample that LFO signal at this 128 or some fast pulse, and it allows us to get smooth modulations that are still quantized, which is nice. So I'll show that a little later. But you'll notice in a lot of these tabs, there's this part that says clock, P clock. With this, all that's happening is that this 16th note counter is being sent with this send clock signal. It's just being sent. So essentially all I'm doing is just borrowing the clock from this first tab in some of these other tabs. So if I turn it on, it's now passing through. And let me just turn the audio down a little bit. So let's actually make some sound now. So this is our simplest example, and as we understand, we're receiving the clock, and let me just drop an object in here to show that clock. So you see that what we're getting here is exactly the same as what we're getting in the first one. We're just sharing it over. And I'm finding the way a lot of these systems end up getting a lot of these systems, and the way these systems end up getting organized is I first have a clock, then I have some kind of pattern generator. So this is merely just generating a pulse of, I am recording, thank you, Wambui. And the software is called Max MSP. And it's from a company called Cycling74. I'm responding to questions in the chat. And I will say, if you're interested in getting into production, this is a good way to do it if you would like to spend 2 years coding and then make music after. That's kind of a joke, but it's, yeah, I think, and I've said this a few times in the course, and I think it bears repeating, like, there's a lot of, in the Max world, there can be a lot of obsession with technology and complexity and building your own, writing your own code and building your own software. By no means is the music better. I think that any way anybody makes music is good. This is one really fun way that I love to use, but I would not tell anybody to use this who wasn't, interested in building stuff. If you just want to make music, there's so many tools out there. And sometimes I even find myself thinking, man, I should really just learn to be more creative with the tools that already exist. Like if you were to only use Ableton Live, you could make amazing music, and so many people do. But this is also extremely fun, and I love it, and I'm happy to share it. And I think the result is you make stuff that you wouldn't make otherwise, and it's a cool way to sort of innovate. It's a cool way to develop new ideas that you wouldn't develop using more traditional equipment. And I think there's an interesting process, by the way, just as I'm talking about this, where the ideas that people generate in these sort of freer, more complicated, or like more flexible spaces where you can build anything, those ideas end up filtering down, right? Like, and I think I mentioned in the last course about how a lot of software like Ableton, or even like there's an FM synth from Electron, I think it's called the Digitone, that they actually built the prototype in Max. So a lot of people will use this to, workshop ideas, figure out ideas, and then they might make a piece of music software that other people use. All right, so back to this. The way that these patches generally work, and you can think of them as, it starts with a clock, then it goes into some kind of pattern generator, then it goes into some kind of value generator, which most of the time is notes, like a Midi note. And so all that's happening here is we have a pattern that's triggering a note, and in this case it's literally just 60, which if you're like a music person, I can change to actually be Midi C3. And then this is a device that turns that simple value into a Midi note, which requires both the note on and the note off elements. So let me show that. So like when we send, and I'll actually extend this a little bit. When we send a note through Midi, what we're actually sending, like say we press a key on a keyboard, we're sending two values. One is the pitch, which is this 60, or the note, and the other is the velocity, which is this 100 you see. And that starts the note, and then that note is ended by a 0, a 60 0, or whatever the note is, and 0. So this device automatically generates that for us. We just send a pulse and we say 60, and in this case it's going to wait 250 milliseconds because of this duration, and then it's going to send the note off 250 milliseconds later. And then that goes to a Midi output, which is just flowing into Ableton here to trigger this very simple, like mallet sound. So if I come over here, there's kind of two algorithmic processes happening in this patch. The first is this pattern generator. So we're using Euclidean algorithm to actually generate this rhythmic pattern. And I think you've seen this in the past, but I'll play with it a little bit and you can understand how it works. There's three parameters. The first two are the most important. This one is the total number of steps in the list. So if I change this, you can see we're changing the number of steps in the loop. And then this second one changes the number of actual trigs or notes or gates that exist in the loop. So the number that are highlighted in green. So if I decrease this, I'll have fewer. And it uses a Euclidean algorithm which will basically space these notes out, or these gates out, evenly across the steps. And so what's really cool about this is with a single parameter, and there's an example later on that will really show this in action. With just two simple parameters, or even just this one, just the trigs, you can actually change the density, essentially, of your rhythmic pattern. And it also is worth mentioning that people have done musicological studies where they have shown that this Euclidean algorithm appears in all kinds of music throughout the world. So, Brazilian samba, or lots of Indian sort of rhythms, traditional classical Indian music rhythms. It's not that the people were applying this algorithm, but that they sort of naturally produce rhythms that follow this kind of logic. So using Euclidean algorithm is a really good way to get musical rhythms very easily. And I just love this fact of being able to change the density of the rhythm with just the one button. This rotate, all it does is shift left or right where these gates actually occur. So if I go up, it's going to shift to the right. And if I go down, it'll go back the other way. So one thing that I sometimes do is I could add a loop here at I will show you. So we have a device here that is now just going to count to 16. And each time it does that, it's going to basically tell me how many times it's counted to 16. And I can feed that into this rotate, and I can actually modify the pattern. Every 16, it'll jump. So this is like another example of a way to make these kind of generative patterns more complex and sort of make them self-evolving by having the pattern modified by the looping of the clock. And if I want to make that happen less frequently, I can totally do that. Let's say 22, so it's every 2 times this goes around, it shifts it. So that's the first sort of algorithmic element here. The second one is this scale object. So what I've done here is, this is a device that will basically allow me to pull up many scales. And if you use Ableton Live, you'll probably recognize these because they're very commonly used in like the scale object and other things in Ableton. So I can pick one and it will just give me those options. And then here I have it in probability mode. So what that means is that it's going to select the notes based on the positions of these sliders. So right now I have the 60 one all the way up, and I have all the other ones all the way down, so we're just going to get 60. But if I increase this one, now we're getting some of that. And if I add a little of this and a little of this, now it's playing through this scale. Actually, I like this here, Joshi, one more. We'll increase the density a little bit. And you can weight which note appears most often. So say I wanted, always, or for most often 60, and then occasionally one of these other ones. I can do this. So we get these melodies that they're still musical because they stay within this scale. So it's not just pure random, but it's constantly changing. And it's sort of constant, it stays around this root note of 60, but sometimes it improvises in this other range. So it has a musical quality without being the same thing over and over again, which I like a lot. I'm interested in things that change, that allow the mind to stay interested, but maintain a sort of consistent pulse or groove or kind of vibe. Because we like both. We like consistency and we like change. So how can we balance between those two? And this is one way to do that. So let's move to another example. And let me just pause. If anybody has any questions or comments, you can either jump in, just unmute yourself and talk, or use the Skillshare chat if anybody's got a question. Okay. So now this is another example of a pattern generation technique. So we talked about Euclidean. This is another example. So this is called a Markov chain, and it's basically a primitive machine learning. It's probably the simplest machine learning algorithm. And what it basically does is it takes some training data, which you can see here. So this is the sequence that we're using to train the machine learning model. And the way that the model works is that it basically says, for each step that comes along, it's going to look at the model and decide what to do next. And the way that it does that is by looking at the history. So if it, let's just put it as a one-order model. So if the current step, so let's say we're currently on this first step. If the current step is green, meaning there is a node, it's going to look up at the model and says, all right, if I look at all the other green steps, what is the probability that the preceding step is green? And then it will, based on that probability, decide what the next step should be. So say, in this case, it's probably higher than 50% probability that the next step will be green. So the next one will most likely be green, but might not be. That's the first order. This order thing allows us basically to look back more than one. So if I say 2, what that means is, say now we're a little bit further on the sequence. Say we're on this second one, and now we're trying to decide what this third one's going to be. And so the sequencer knows that it's already had an off and an on, or a gray and a green. And it's going to look at the examples where gray and greens exist. So here's one, there's one over here, there's one over here, there's one over here, and say, okay, what is then the probability of an on or an off there? And then it will decide. So the effect is that it's able to basically make patterns that are sort of similar according to this probability model. Oh, here's a good question. How would you, instead of applying probability on notes within a scale, apply it on switching between different sound samples altogether? Really cool question. So the way that I would do it is, I'll go back to the Markov thing, but I love Saad's question. So Saad asked, how would you, instead of applying probability to notes on a scale, apply it on switching between different sound samples altogether? So let me actually do that. So I'm going to make just another instance of this. Oops. Oh, you just advanced to level 2. Congratulations. I'm going to make another instance of this device. And what I'm going to do, so if you can see over here in Ableton, I have a few different instruments, and they are each on a different MIDI channel. So they're all coming from this From Max 1 MIDI device, but they're on different channels. And this is only one way to do it. There's, if you're using, say, a drum rack, like this is a drum rack, this third track. So each note is a different sound. So in that case, the notes don't play pitches, they play different sounds. But in the case where I have an instrument that's a pitched instrument, like this mallet, right, the notes are pitches, and now how do we change the sound? A way to do it might be to send a different MIDI channel so that I'm actually playing a different instrument. So if I connect this, and what I'm going to do is I'm actually going to create a new scale that is simply for the purpose of switching between this MIDI channel 1, which corresponds to the one we've been playing, and MIDI channel 2 that corresponds to this other sound. Okay, and then I'm going to save that, and I'm going to select it. Oops, I need to dump. Did it work? I think I need to move this so that my menu actually appears. There we go. And, oh, this needs to be 0. Cool. So now, let's test it. It should be that when I play this, I either get a 1 or a 2. And now I can put that into the MIDI channel input of my MIDI out device. So it will change what MIDI channel this note information is going to. And you can tell that it's actually now using that probability to change between these two sounds. And let me change this one so you can hear it a little bit better. It's very high. Let me see if I can fix that. So if I set it like this now, we're really getting mostly that first sound and less the second one. But if I flip them, so I think that was a great question because it demonstrates one of the sort of important themes here, which is musical information like notes, velocities, MIDI channels. They're all just numbers, right? So we can use numbers in all of these weird ways, right? Another thing that we could potentially do is, so we have this MIDI section. Now I'm over looking at the Ableton device. Let's see if this works. So we have this MIDI section that will allow us to actually change the sound parameters. So in fact, it looks like the modulation wheel goes to this resonator 1 hit. Let's just hear what it sounds like when we play around with that. Cool, we can totally hear the difference. And I know that modulation wheel is control voltage channel 1. So if I do a oops, there we go. And I'm just going to send this control and let's actually just simplify here. So now we should be modulating that hit. Yep, we can hear that now. And I'll actually add one of those Ableton Midi monitors. Oops, I'm in the wrong channel. So you can see here what this is telling us is we're receiving this control change, MIDI control change, these different values, and we have our MIDI device. MIDI control change is the same as modulation wheel. And we're telling the computer to change this resonator 1 hit parameter according to this incoming value. So there's another great example of all we're doing is working with numbers here, and we can use them in lots of really interesting ways. So now we can change our sound. See if we can do something that's even more obvious. I wonder what this will do. Oh yeah, the panning. So this is change. I don't know if you guys are getting the stereo panning, but this is going to move the sound left and right. Cool. Okay. I know I stopped halfway through this explanation, but I think, so I explained how this model works. Essentially, the result is it's going to create a pattern that's very similar to this one here. And thank you, by the way, for that question, Saad. That was awesome. Let's do it. So now I'm playing a different sound here. Turn it up a little bit. So this is, again, the top row is the training data. Essentially, I just punched this in with my mouse. And now it's automatically generating patterns for us. To try to match what it's seeing. Which is pretty cool for drum stuff. And I can just change the pattern up here, the training data, and it will automatically adjust what it does. So now it'll basically never do 3 in a row, because 3 in a row doesn't exist in the training data. But if I do, say, this, now you see we're getting more often repeated sequences of many notes. And one thing that we can do then to make this pattern a little bit more interesting is, oh, thank you, Wambui, Yeah, it's nice when it actually sounds good. It's not just interesting conceptually. So one thing we can do to make this more interesting, or sort of give ourselves more options, is we can see here what it's doing is simply passing through to actually pick the note. So actually, this is going back to Saad's question, how could you use this to change the sound, right? In this case, I'm using an Ableton drum rack because I have MIDI channel 3, which is channel 3 here, and it's just triggering different drum sounds. And the way that it's actually picking those is this Markov pattern generator is basically just acting as a gate that either allows the clock value to pass through or doesn't allow it to pass through. And you can see the value is very big. It's like almost 18,000. And that's because I have a little thing in this Markov device that's just going to wrap that value around. So the actual value that the Markov device is using is between 1 and 8. And it's basically just using a what's called a modulus. So let me show you an example. If I say modulus of 8, it's counting from 0 to 7. Because computers always start at 0 and math often starts at 0 too. And all the modulus is the remainder when you divide. So if I do so this 18,000 blah blah divided by 8 is 2003 blah blah point something. And if I take that point something part and I multiply that by 8, this is what I'm going to get. So that's what that is. And that just allows us to get from this really big number a value between 0 and 7 that allows us to cycle through this sequence. So one thing we can do to make this more interesting is just basically change how that logic works. Like perhaps it, instead of counting linearly like this, maybe it counts backwards, maybe it picks randomly, maybe it uses a probability. There's a whole lot of ways to think about that. And so in the next example, we'll look at that, which is this sequence traverse. So in this example, we have a Euclidean one, which I'll put some notes into. Actually, no, I'll start simple. We have a Euclidean one, and then we have this loop, which we'll talk about. Then we have our sequence generator, and then we have our MIDI note creator that we know about, and MIDI output to the same instrument. So, and what these things are doing is controlling some of these devices. So let's just start it, and we'll decode what's actually happening. So you can hear, we just hear this one kick drum. And that's because we have just one trig, and this device is doing two really interesting things. The first is it's actually doing basically a more complex job of this modulo that we already talked about. So if I have modulo 1, it's just going to give me 0, 0, 0, 0. So if I add 1 to that, oops. It's going to say 1, 1, 1. And that is telling this device to just give me the first step, the value, which is 38, which is this kick down here, kick glitch 11. I can play more of those, so I can increase the density like this. So this is basically all I'm doing when I click this thing, is just controlling this little trigs number. And in fact, if I do it here, it'll change over here. So now we have like a gabbery kind of thing. Let's go back to 1, or maybe 2. if I change the length of this loop, it will allow me to count from 1 to some other number. So let's say 2. So now it's changing back and forth between these two sounds. If I go to 3, okay. Now this is the offset. So this is basically, again, controlling this loop device, and is going to basically shift what's actually being counted. So if I go to 2, now we're counting, instead of 1 to 3, we're counting 2 to 4. And then this final one, again, controls this loop device and basically allows us to count forward or backwards. So now we can count backwards. And then you can just have a ton of fun by just playing with these. So this is the thing I've been kind of working on doing more, is having these interfaces that control the devices that are very simple, that'll make it very fun, particularly for live performances. So I have a show tonight actually where I'm going to have a UI that looks a lot like this on an iPad. And the iPad controls the computer. So I don't even really have to look at the computer, I don't really have to use the mouse, and I can just press these buttons, and it's kind of these like grid type of buttons, and change the pattern. And it's fun to find things that sound good and just sit in them for a little bit. So if you imagine we had that Markov chain, like we could do a thing where, in fact, I can tell this Euclid device to give me its sequence. So this is just a 0s and 1 representation of the sequence that it has loaded in. And I actually can feed that into uh-oh, what did I do wrong? Oh. Need to create some space for myself here. So what we're going to do now is use this Euclidean clock just to give the training data to the Markov. So we'll say listen. So when I change this, now what I'm doing is changing the trading data that feeds into the Markov model. I have to press this listen button to get it to actually pay attention to me. Let's make this a little bit bigger. So sort of using two of these techniques in conjunction with one another is cool. I could even say, we could say j.send tr mark learn, and then over here so now what I'm basically doing is just having it be so that every time one of these buttons gets clicked, it activates the learn and it changes the pattern and changes what's going into that Markov generator. This is pretty cool. I might put this in my new live set. All right, what else do we have? So pattern interaction. I think I showed this a little bit last time. This is kind of interesting. And actually, this is getting a little bit to Saad's question from before. So in this case, we have two patterns. One is a Markov style, one is a Euclid. And what happens is that I'm trying to remember. Oh, each time the one on the right, the one on the left goes, each time the one on the right goes, the Euclid, it will basically prevent the one on the left from passing through. And then it will play, the one on the right always plays its sound on the second channel instrument. So the basic bright, the second one, and the instrument on the left always plays its sound on the one on the left. So basically, these two things are never playing at the same time. I'm going to slow it down. So they're both selecting from this same scale, which is really nice. And they're actually just picking randomly. But basically, anytime this has something to say, this one won't, you won't hear this one. These two instruments never play a sound at the same time. And that's because this gate object, all this thing does is say, for this is the input, where is this input data going to go? Is it going to go either nowhere? If the value here is 0, it'll go nowhere. If the value is 1, it'll come out this first output. If it's 2 here, 3, 4. So this device is actually sending either a 0 or a 1. If the light is green, it's sending a 0. If it's gray, it's sending a 1. Meaning, if it's gray, anything that this device sends is allowed to pass through. If it's green, meaning this one is outputting a note, then anything that this Markov device is putting out is not allowed to pass through. And then that same information, the 0 and 1, is being used to direct the signal between two different outputs, between two different channels. Probably actually a nicer way you could do this would be to just plug it straight into the Midi channel. So this has the same effect. Basically, if this one comes, if there's a note here, if it's green, it produces a 2. If there's no note, it produces a 1. And these devices here are just like, the device itself just puts out 1 for the green ones and 0 for the gray ones. So these two little like math things just, in this case, flip it around so that 1s become 0s and 0s become 1s. That's this one. And then in this case, it just adds so that 0 becomes 1 and 1 becomes 2. Oh, and we're already at 10. I did not even notice. Time flew. I'm just going to keep going. If anybody has questions or comments, put them in the chat. I'm watching it. And I'll just keep going until I'm done or everyone leaves. Okay, here's another example. This is probability. So in this case, not using probability for note selection like we did over here, but rather using probability for the pattern. So here we have 2 probability devices. Let's ignore the one on the right for now. And we'll just set it to 0. And then the one on the left is the one we care about. And so what's going to happen is, each time this device receives a clock, 71% of the time it will send that information through, and 29% of the time it won't. So I can, similar to how we were talking about, we can change the density of patterns with the Euclidean object by changing that trig value. We can do the same here by changing the probability. And then taking an idea, borrowing an idea from our sequence traverse example, which was this one. Instead of just always stepping forwards through this sequence, we can actually have it do what's called a drunken walk. A drunken walk, all it is it doesn't actually care what the incoming number is. It just treats that as a, hey, give me a number. And it's going to give, this device will give a number between 0 and 7. And each new value that it gives will always be either the last value it gave, the last value plus 1, or the last value minus 1. So it's different from pure random, where random is just going to jump around randomly. Random is just, each time this thing gets hit, it's going to put out some random value between 0 and 7. Drunken walk, it has an element of randomness to it, but it's actually only ever going to go up or down one step, or it'll play the same note. So you'll hear more of the repeats way more often. And it kind of respects the order of the pattern more. And then this earn example is like the random, but it will actually go through all the notes once before it repeats. So it will never repeat something until it's played all the others. I wonder what this will sound like with the drums. right, so now let's talk about this one over here. So this device is very similar to the make note one that we've seen before, in that it does this basic thing of turning just a number, or in this case a pair of the number and a velocity, into a note that includes the note off, the Midi note off. But it also has this cool feature of being able to do like a retrigger or like a ratchet or a roll of the last thing that it received. And the way that we get it to do that is by passing a 0 rather, into this input. Because its default behavior is to produce this retrigger. So right now that feature is basically being bypassed. But if I say 0, it will do what it wants to do, because I'm telling it to not bypass that retriggering feature. So now each note that comes in is being retriggered. And the way that it's actually doing that is it's retriggering it, but it's each time it retriggers, the velocity decreases down to 1. So it's going to retrigger 12 times at a rate that is double the rate of the incoming clock signal. That's what this 2 is. And I'm actually passing the clock signal into this device. And over those 12 retriggers, it's going to go down to a velocity of 1, which is why it feels like an echo that's fading away. So now we can use the probabilities to actually control when that happens. So 20% of the time, it will do that. If I don't want it to fade away so much, I can actually turn that off. So now if I click off this on button, I turn it to off, you'll hear that they don't fade away, they just repeat at the same velocity. This is wrong. It says output velocity is 1, but it's actually incorrect. It's just going 100, 100, 100, 100, 100. But I like the fading away a lot. I think it's nice. We could also make it go up. So we could do something like this. So what I've done now is, this probability device is just putting out a 0 or a 1, right? Anytime it receives a bang from this clock, it says, okay, 20% chance I'm going to give you a 1, 0, or 80% chance I'm going to give you a 0. Then I actually flip that around so that so that 1s become 0s and 0s become 1s. And then I multiply that number, 1 or 0, by this static velocity of 100. So basically, if this is a 1, meaning this has produced a 0, which becomes a 1, then the velocity, then it's not going to be retriggered, and the velocity is going to be 101. If this does produce a 1, then it's going to cause the starting velocity to be just 1, and it's going to be re-triggered, ramping up to 100. So now you can hear this opposite effect happening, where instead of the repeats fading away, they're growing, and they're getting louder, which I think is pretty cool. Oh, Sod is typing. Oh, thank you. I will check that out. Thank you for coming, Sod. Thank you for sharing that music. This is sounding really nice. Maybe I should record it. On my currents channel. Okay, one more thing to demonstrate is this idea of the clock signal itself being the tempo, the BPM being modulated by a, in this case, a sine wave. Go back to our nice bells. I like them. So I have a clock. It's sending out two things. The first is just a 16th note pulse. And the second is an ultra fast 128th note. And that 128th note is being used to get a value from this sine wave function. So I have this device that says, give me a sine wave, and each time you receive a little impulse from the clock, give me the next sort of value, sample the next value in the sine wave, and scale that value to something between 85 and 95. And I can change sort of the speed, quote unquote, of the sine wave by changing this steps function. Basically what this means is how many events, how many triggers does it take to get from the beginning of the sine wave to the end. And I can change what the function is. So I could actually do these easing functions are kind of like these different kinds of ramps. So you'll see it's not going to change very much, but then it'll quickly ramp up according to this kind of exponential pattern. You'll start to see that happen really quickly now. Here we go, it's speeding up, and now it's back down to 85. When it hits the limit, it goes all the way back. We can increase this a little bit to make it a little bit more pronounced. Oops. Let's bring this down to like 80. Really make it pronounced. Try something crazy. Yeah, that's kind of cool. And then if I want to, instead of using this function, so now I have, this is a switch, so it's basically going to tell me where it's getting information from, whether it's from this function or somewhere else. In this case, now I'm telling it, listen to my Midi keyboard that I have. So now I'm physically in my studio touching a Midi keyboard. And I can change the note that way. Actually, if I do this, I can just use this kind of virtual one. So another great example of like musical data being just used as numbers. I'm not really, in this case, I don't care at all about the fact of the Midi note being a note. It's not changing the pitch of anything. It's just changing the speed of this pattern's playback. And for a little bit of a dive into the actual max guts, this thing is just producing a Midi note value, which is going to be like 60 or something, right? But that then is getting converted thanks to this very helpful scale object into something roughly between 40 and 200. So this type of object, and one of the reasons Max is so great, is it really makes it easy for you to just work with numbers and think about numbers and convert numbers that are in one range, say, that are as useful for, say, Midi, into another range, right? Because 0 to 127, or whatever the bottom of this is, 36 to 83 is not particularly useful as BPMs. So, but it's easy for us to convert that into something else that is useful as for BPMs. I like that speed a lot. And then as one final demonstration, I could have it do this on its own. So I could use another one of these loops. And we could say every 16 steps, we could get a random value. So on this loop thing, the first output is going to be like the step, so basically the same as this. But this third output on the right-hand side just counts how many successful loops there have been. So it's a really easy way to get a trigger every time a loop is completed. And so I'm going to say, just give me a random value between 80 and 150. And then I'm going to plug that in here, and I'm going to give this a 3. And hopefully that works. There we go. So now it's really generative because we're actually just sequence as it goes, it changes things. I suppose the function was generative too. Keyboard, not so much. Thanks, Monraya. Okay, I'd say that's about it. In the Discord, you can @ me, you can DM me if you have anything to say. Thank you everybody for being here. And next week is going to really be for the people that are interested in using Max. I'll be sharing some resources on how to learn it, what other people are doing with it, some examples. I had kind of a list of other really cool projects that are similar to this one that I wanted to uplift. So we'll share some of those. And knowing that we have some folks like Wambui who are interested in getting into production more generally, I'll think a little bit about, well, how does Max, I think one thing that's interesting for folks is, how does Max connect into a wider music production setup? Because some people, they make Max music fully inside of Max MSP, which I actually don't do. And I think one of the things that I get excited about is the idea of being able to say, take advantage of all the really cool sounds that you can make in Ableton, right? So I just use, I use Ableton Live, I use their devices, I use some other VSTs, like this really awesome chromophone thing, which I, for some reason, can't get to open, but I use samples, all these things, and I just find that devices like, Ableton Sampler and things like that are great and they work, so I just use them. And then on the Mac side, all I'm doing is producing like musical data, right? I'm just producing sequences. There are people who do all of their work, like they do their sampling or their synthesis or all their sound creation in Max, and that's really, really cool. But one of the things that's beautiful about it is that you don't have to do that. It's very flexible and you can connect it to anything. So I'll talk a little bit about how that works as well. Okay, thank you everybody. Is there a way I have one question. Should I end the session? Is there a way I do that? Oh, that's a good idea. Okay. That's a good idea. I can't find this end now. Okay. The X. Oh, there we go. That was easy. Yeah. I was overthinking it. Okay. Thank you. Have a nice evening. Bye bye.